Okay. So we have started diffusion, right?
Yes.
So we have completed till here, Khatija.
Yes.
Diffusion, it is the movement of particles from the higher concentration to the lower concentration, or further we can say spreading of the particle, or we can say mixing of the particles. And we have seen few examples. Yeah, smell of the perfume or smell of the food when it was cooking. In the similar way, when a ink is dissolved in water, so it is spread and mixes with the whole water, so the whole water get a uniform color. Same example, when we dissolve roux afza in the glass of water, same diffusion will occur. Okay. So further, what we have discussed that to for a substance to diffuse, it needs a gaseous or liquid state, right? And it is why, because there are spaces between the particles in the gases and in the liquid phase. The particles are little far, that are at a little distance, so they have a spaces in between them. Yes, we have noted down till here, I assume.
Yes.
Okay, so now we are going to discuss factors. So one is the temperature. So at higher temperature, the particles have higher energy. That's what we have discussed earlier as well. So if they have a higher energy, they will going to move faster, which means that the rate of diffusion is going to be faster. And at lower temperature, the particles have a lower energy. They move slowly, which means their rate of diffusion would be slower. Is this understandable?
Yes.
Okay. Note this down. Done. Yes, Khadija, have you noted down?
Yes. Yes.
Okay. The other factor is the mass, or more specifically, we call it relative molecular mass, which means MR. So the simple thing is that if a thing is heavy, then will it move faster or slower? Slower. And if it's a
Yes.
lighter, then it will move faster. So in the same way, if the gas particles have their relative molecular mass greater, then they will diffuse slowly. And if they have a lighter or lower relative molecular mass, then it will diffuse faster. So how we will get the MR? That is the important thing. See, we say that it is the sum of the relative atomic masses, AR, of the atoms present in the molecule. So from where we get AR? We get AR from the periodic table. Now we will see how we will find it. So see, there is a first example of ammonia gas. The formula of ammonia gas is NH3. Yes, it suggests that there how many nitrogen atoms are there? One.
1,
And the hydrogen atoms are
3.
3, right? So let's have a look at periodic table. If you look at this key, see what it is telling me, that the value at the bottom is relative atomic mass, which we called AR. Okay, Khatija?
Yes, sir.
So for nitrogen, the AR is 14,
14.
and for hydrogen, the AR is 1. So we got the AR. So what we do, we put the AR, there is a 1 atom of nitrogen times 14, because its mass is 14. Then there are 3 atoms of hydrogen, its mass is 1. And then we add them, so we'll get the MR of ammonia. Is this clear?
Yes.
Okay. After noting down this, I want you guys to find the AR of HCl. Done? Yes, I
Yes.
will show. Okay. So, oh, it's just taking time. I have opened it. Are you seeing the periodic table, Khadija? Okay, now here we go. $36 or yes, Khadija, have you calculated?
Yes. 36.5.
36.5. It's 35.5, right? See, the rest of the one all are in a whole number, but it's in a fraction, in a decimal. So we have to use it in a decimal. Okay. So it's
Yes.
36.5, right? Now for carbon dioxide. Yes. How? How? Why we multiply 12 and 16? 12 is the AR of carbon and 16 is the AR of oxygen. So we add them, we multiply 16 by 2 because there are two oxygens. Khadija, have you calculated the MR?
Yes.
What is it?
44.
44. See, there is one atom of carbon and its MR is 12. Then plus, there are two atoms of oxygen and its AR is 16. So 16 times 2 gives you 32 and 12, which will give you 44. Is this clear now? Okay. So the heavier the MR of the gas molecule, the slower the rate of diffusion. And the lighter the MR of the gas molecule, the faster the rate of diffusion. Yeah. Yes, Khadija,
Yes.
have you? Okay. So there are some chemical reactions that are used by the examiner in past paper for the diffusion experiment. So we will discuss how they are used. First write the equations that see it's ammonia gas and it's a colorless gas. And it's a hydrogen fluoride gas. It is also a colorless gas. When these two meet, they react, and on reacting, they are going to form a solid, that is ammonium chloride. In the similar way, these two reactions are taking place as well. If you see the format of the equation, it will be same. See how many hydrogens are bonded to nitrogen?
3.
3, and there's the one hydrogen over here. So after reaction, these all hydrogen combines to give you NH4 and Cl stays. Here, 3 hydrogens with the nitrogen and one hydrogen over here, both combines and Br stays. So I feel like how many hydrogens are over here?
5.
5. But not all 5 are bonded with nitrogen. See, because CH3, which means that these 3 hydrogens are actually bonded with this C. And then NH2, it means these 2 hydrogen are bonded with H, with N. So there is a one hydrogen. So in the same manner, this NH2 becomes NH3 and Cl stays the same. So see, all the reactions are taking place, are occurring in the same format, in the same way. And all of these are gases and they are going to form solids, white solids. Is this understandable?
Yes.
Yes, Khatija. Okay, note these down. So these are the chemical reactions that we normally involved in diffusion in the exam. Was Manal. What was your name? Yeah. Khatija, are you done?
Yes.
Okay. Now, let's have a look at this question. A student set up a tube as shown in the diagram. On the left side of the tube, there is a cotton wool that is soaked in hydrobromic acid. And on the right side of the tube, there is a cotton wool which is soaked in ammonia. So it means here they are talking about these two things in the second equation, ammonia and hydrogen bromide. Okay, Khatija?
Yes. But sir, they haven't mentioned
Sorry.
hydrogen bromide.
Instead, what they have mentioned initially, if you see, they have mentioned hydrobromic acid. But if you read the statement, which is below the diagram, you will see concentrated hydrobromic acid produces fumes of hydrogen bromide. So it means initially it was a solution of hydro. That is the important thing that you have to understand. Here I have written in the first equation hydrogen chloride gas, and the symbol is G, right? So if that, when I dissolve this hydrogen chloride gas in water, it will become a hydrochloric acid. Now it is not named as hydrogen chloride. When it's a gas, it is named as hydrogen chloride, but when it dissolves in water, it is named as hydrochloric acid.
Okay.
Do you understand? In the same way, HBr is a hydrogen bromide, and it's a gas right now, so that's why I'm calling it hydrogen bromide. But if it's an aqueous, it dissolves in water, I call it hydrobromic. Okay, so what they are saying, okay, so what they are saying that concentrated hydrobromic acid produces fumes of hydrogen bromide. So it means the molecules of hydrogen bromide escapes the aqueous phase and turns into vapors. That first statement. Concentrated aqueous ammonia produces fumes of ammonia. So in the same way, the ammonia particles, the ammonia molecules escapes the aqueous phase and turns into vapors or gas. Is this clear?
Yes.
Okay. Now, if they become gas, gas moves. So where they will move? If you look at hydrobromic acid, where it is on the right, left side of it, that is blocked. So it is going to move towards right. And where the aqueous ammonia fumes are formed, the right side is blocked and it is going to move towards left. Is this clear?
Yes.
Okay. Now, what they are saying in a part, after some time, solid ammonium bromide appeared on the walls of tube at point X. So it means that the point X where you are looking at the diagram is the one where they both collide with each other. And when they collide, they reacted and form ammonium bromide according to the equation as we have written earlier. Clear?
Yes.
Yes, Katika? Okay. Now, if you look at that point, it is very close to hydrochloric acid and far from aqueous ammonia. So, what is actually conclude from this? It means that both gases take same time to reach at that point X. Obviously, they reaches at point X. Whatever the time it took, ammonia travels more hydrogen bromide. Is it clear? Yes, Khatija?
Yes. Yes.
So If it travels more distance, it is giving me a hint that ammonia is faster. Is slower. So the rate of diffusion of ammonia is faster, and the rate of hydrogen bromide, the rate of diffusion of hydrogen bromide is slower. Why?
Because of MR.
Is heavier. Yeah. Good. Did you understand, Khatija?
Yes.
So see, they are asking for 4 marks. What to explain these observations? So see how we will explain it. It's again stuck. See, HBr molecules and ammonia molecules escape aqueous state and turns into gas. It will award me the 1 mark out of these 4. Then HBr and H3 molecule diffuses from their higher concentration to the lower concentration. At point X, these molecules collided, reaction occurs, and white solid appears on the wall of the tube. Is this understandable? Yes, Khatija?
Yes.
If you want to take the screenshot, take the screenshot. Yes. Now, yes. Who is going to tell me the A1? First, read it very carefully and then answer it. If you have any ambiguity in the comprehension, to ask. Yes, but read the question. In this question, they are not asking which one, why their movement is faster and why the movement is slower. Here, they simply asking how the gases move through the tube. Yes, and what that phenomenon is called? Yes, Khatija?
Uh,
Isn't it diffusion? Right? So see,
yes.
that's how they examiner trick. So the answer would be diffusion. So gases move due to diffusion in which molecules move from their higher concentration to the lower concentration. And for second mark, but for second mark, actually here it is. Why the gases have taken different time to reach the litmus paper, that's what you are answering me. That is, the one gas is taking more time and the other gas is taking lesser time. So the one which is taking lesser time have a lower MR and the other one have a heavier MR. Is this clear?
Yes.
Okay. So here they are asking you to draw the liquid bromine. So we can show the liquid like irregularly arranged particles, but close to each other, right? Because in liquid, the particles are not very far. They are closer, but irregular. Okay. Now, yes. But initially, the bromine is in liquid state. And if you look at the amount of liquid at the start, it is more as compared to the amount of a liquid after 30 minutes in the diagrams, right? Yes, Khatija?
Yes.
So it means first the particles escapes the liquid and turns gas, and then what you said that they mixes with the air and diffusion occurs. So it's for 3 marks. So see how we will answer it. If you want to take the picture, click it. So bromine molecules which have more energy escapes, liquid phase turns into gas, diffuses as a result, it mixes with air in the flask and the whole flask turns. Yes, that's what we say. That liquid phase escapes the liquid phase and turn into gas. Turning into gas means evaporation. So first they evaporate, then they mixes, and as a result, the whole flask turns brown in color. Is it clear,
Yes.
Khatija? Have you took the screenshot?
Yes.
Okay. Yes. Who will answer me in this part A?
It is a gas.
At 25 degrees Celsius, butane is a
Gas.
gas. That's Khatija is saying. What do you say, Manavil? It's a gas because 25 is higher than its boiling point. So explanation would be boiling point of butane is -6, which is lower than the room temperature. Is this clear, Khatija?
Yes.
Okay.
सर आप एक्सप्लेन कर देंगे लिक्विड कब होगा सॉलिड कब होगा
Sorry.
लिक्विड कब होगा सॉलिड कब होगा पीवी स्टेट अगर इन चार्ट में
देखें, it's easy to figure it out. See, if the temperature they have given you is lying in this range between its melting point and boiling point, then the state of that substance would be liquid. When the temperature is higher than its boiling point, then it means that the substance is a gas. And if the temperature given where the examiner is asking the state is lower than the melting point, then the substance is in its solid state. Is it clear? Yes, Khatija?
No, sir.
What you
Sir, C5HN. So how will you able to is it is it a liquid or a solid or a gas?
देखिए हम ये किसी एक स्पेसिफिक टेम्परेचर पे फाइंड आउट कर सकते हैं. फॉर एग्जांपल अगर हमने बोला कि इसकी जगह पे होता, यहाँ पे जो ब्यूटीन दिया हुआ है, इस ब्यूटीन की जगह पे होता पेंटीन, जो आपकी साइटोस्केन कह रहे हैं, और वो कह रहे हैं कि इसकी रूम टेम्परेचर पे स्टेट बताएं. तो रूम टेम्परेचर आपको याद होना चाहिए 25 डिग्री सेल्सियस है. ठीक है.
Yes.
अच्छा, अब अगर मैं देखूं तो ये इसका बॉइलिंग पॉइंट है, तो 25 डिग्री सेल्सियस इसके मेल्टिंग पॉइंट और बॉइलिंग पॉइंट के बीच में आ रहा है.
Yes.
इट मींस इसकी स्टेट रूम टेम्परेचर पे क्या हो जाएगी? लिक्विड हो
Liquid.
जाएगी. आई बात समझ?
Yes.
इसका तीन चार तो क्लियर हो गया.
Yes, sir.
ओके. अच्छा तो ये क्वेश्चन देखिए, इसका स्क्रीनशॉट लीजिए. ले लीजिए. ओके. अब दिस इज एमसीक्यू. सी if you see there is a porous spot inside. This is the porous spot, right? What does porous spot means? There's this spot have a very small pores in it, holes in it, and if there is a hole, then it means gas can diffuse in and diffuse out, right? Yes, Khatija?
Yes.
So they are asking that which gas when present in the beaker is this. So it means they are asking about the gas in this region, that which gas is present in this region will cause the water level at Y to rise. It means that which gas will be over here, which will help the water level to rise over here. Did you understand this, what they are asking?
Yes.
They are saying, see here inside the porous spot there is oxygen, as they have mentioned, and outside the porous spot, and but inside the beaker there is some other gas we don't know, and they have asking which gas is present in the beaker. It means over here, which will cause the water level at Y to rise. It means which gases will be over there. If that gas is over here, then as a result that water level at here would be rise. Now did you understand? Yes, Khatija?
Yes. Yes.
See, for example, if there is some gas X over here, right now we don't know which gas it is. If there is a pore, the pot is porous, it have a pore, so it means that X gas will going to diffuse in and oxygen is going to diffuse out. If both gases diffuse with the same rate, then inside the porous pot the number of molecules remain same. So the pressure over here would stay same, and as a result the level of water on both the positions will be the same. And if both the gases are diffusing with the same rate, it means the MR of both the gases will be the same. Now think, if X is a heavier gas, X is a heavier gas and oxygen is a lighter gas. So oxygen will going to diffuse out more and X would be going to diffuse in less. So in the porous port, there will be lesser molecule after some time because there more oxygen goes out and less X comes in. So it means that if there will be lesser molecules in the porous port, the pressure over here will be lesser because there are
Yes.
less molecules of gas now, due to which if the pressure decreases, so the water level over here is going to rise and water level over here is going to goes down. It's when this gas is heavier, so that it will be diffusing with the lower rate. Now think, this gas would be lighter than oxygen, its MR is lower than oxygen, so it is going to diffuse in more because it is diffusing faster, and oxygen would going to diffuse out less because it is diffusing with a slower speed. Is it clear, Khadija?
Yes.
So due to this, there will be more molecules in this porous spot. So the pressure over here would be increased. As a result, water level goes down over here, and due to this, water level goes up over here. So that is the answer. It means the gas which will be inside the beaker is the one which have a lower MR than oxygen. So if we have calculated the MR of oxygen, so the MR of oxygen is going to be 32 because oxygen is 16, there are two oxygen. So then what we did, we have calculated the MR of each one. So only this one is the one which have a lesser MR than oxygen, and rest of the gases have a heavier MR. So it means this will be the answer. Is it clear?
Yes, sir.
Then, okay. So we will be ending over the class over here, and probably the next class will be at 4 p.m. Okay.
Okay.
Okay. Take care. Allah Hafiz.
Allah Hafiz.